two problems on this topic. So we have to see. Okay. I just add some lines on this. Okay. So suppose a function fx is defined in a period 2L. Let's say there is a function which is defined in period 2L. And as we know that the Fourier series expansion of this function can be written as, in terms of Fourier coefficients, it can be written as a0 by 2 plus summation n an cos n pi x by L and with Bn there is sine n pi x by L. So basically this is your Fourier series expansion. Now I know that if I want to write this cos function and sine function in terms of exponential, then I know that cos x can be written as e raised to the power ix plus e raised to the power minus ix divided by 2, and sin x can also be written as, in this terminology, e raised to the power iota x minus e raised to the power minus iota x divided by 2i. So if I insert, instead of this cos n pi x by L and sin n pi x by L, if I rearrange this, then this expansion, this Fourier series expansion will look something like this. a0 by 2 plus. Okay, I will expand this up to two terms. Let's say a1 and this will be cos pi x by L. For first term n will be 1, so it will be cos pi x by L. So my argument of cosine function is pi x by L for first term. So this cos function can be written as e raised to the power iota pi x by L plus e raised to the power minus iota pi x by L divided by 2, right? Plus a2. The second term, I will evaluate two terms. The second term will be a2 and cos 2 pi x by L and cos 2 pi x by L. So in this term, 2 pi x by L will be the argument of cos function. So I can write e raised to the power 2i pi x by L plus e raised to the power minus 2i pi x by L divided by 2, right? And so on. There will be a3 and there will be e raised to the power 3i pi x by L plus e raised to the power minus 3i pi x by L with a3, okay, with all those terms. And from this part of expansion, I will get B1 and this sign for B1, it will be sine pi x by L. And if I insert this instead of x, if I insert pi x by L, it will be e raised to the power. It will be e raised to the power plus I pi x by L minus e raised to the power minus I pi x by L and divided by 2i. Similarly, for second term, it will be B2 e raised to the power 2i pi x by L minus e raised to the power minus 2i pi x by L divided by 2i. Right? Now, I can see that if I rearrange the terms such that this e raised to the power I pi x by L and this e raised to the power I pi x by L. I want to arrange them. I want to club them. So this term, the final term from these first terms, it will be fx is equal to a naught by 2 plus a1 by 2 plus b1 by 2i and e raised to the power iota pi x by L. Similarly, for this negative term, I can see there is a negative sign here and there is a, instead of 2, there is 2i here. So if I club this term and this term, then I have to write plus a1 by 2 minus b1 by 2i. Right? And e raised to the power minus iota pi x by L. Similarly, for this term and for this term, I can again write same thing, which will be a2 by 2 plus b2 by 2i. And it will be e raised to the power minus 2i pi x by L. And the last term from these two terms, this and this, it will be a2 by 2 minus b2 by 2i. And it will be e raised to the power minus 2i pi x by L. And so on. So I can see that from here, I can see that this e raised to the power I pi x by L is combined with this a1 by 2 plus b1 by 2i. Right? a1 by 2 plus b1 by 2i. And in this case, it is a1 by 2 minus b1 by 2i. So what I can do is, if I further solve this, if I further rearrange this, it will look something like this. Okay, it will look fx is equal to a naught by 2 plus c. What I am doing is I am taking this half as common, and it will become this half as common, and it will become a1 plus b1 divided by iota. And this I will rationalize, and it will become b1 iota divided by minus 1. Right? If I rationalize this, a1 plus b1 by iota, a1 plus b1 by iota, I can do this thing. So it will become a1 minus iota b1. Right? it will become this e raised to the power iota. This was first term, so it was iota pi x by L. Similarly, the second term will also become, if you can see, if you take half common from here, it will become a1 minus b1 by iota. And if I rationalize, it will be a1 plus iota b1. Right? It will become a1 plus iota b1 and e raised to the power minus iota pi x by L. And again, similar thing for third term, which will be a2 minus iota b2 e raised to the power 2i pi x by L plus half a2 plus iota b2 e raised to the power minus 2i pi x by L. Right? So from this, I can see that these terms are actually these terms in which the exponent of this exponential function, the power of this exponential function is positive. In this, I can see that it is becoming a naught by 2 plus, I will write this as a1 minus iota b1, a2 minus iota b2. I will write this as Cn, right? I will write this as Cn. And the definition of Cn is half an minus iota bn. So you can see that this one is C1, right? This one is C2, and the next term will be C3. So I'm writing this an minus iota bn as half of that as Cn. So it will be Cn e raised to the power iota n pi x by L, right? And summation. So all these terms which have the positive power of this e exponential function will be combined in this term. And I'm also defining a Fourier coefficient which is c minus n, which is equal to half of an plus iota bn, which is equal to half of an plus iota bn. So all these terms will be combined in a summation c minus n e raised to the power minus iota n pi x by L, right? So what I'm trying to say is, if I want to find the Fourier series expansion in terms of complex variables, in terms of complex function, then I have to replace my an and bn with this Cn and minus Cn. I just have to calculate the values of the Cn and minus Cn, and then I can express this function in terms of complex variables, right? So, okay, this a naught by 2 can also be written as c naught, right? This can also be written as c naught. So it will be c naught plus summation Cn e raised to the power iota n pi x by L, and for Cn negative of Cn also. And this C naught, okay, from this I can see by the definitions of this new Fourier coefficients, C naught can be evaluated as, just like the previous case, it will be half of the value of A naught, and the value of A naught was 1 by L integration in the whole period function and dx. So this was the definition of A naught. So C naught will be A naught, half of the A naught. Similarly, if I have to calculate Cn, then I know Cn was defined as An minus iota Bn. So it will be half and An. An was defined something like this, 1 by L from integration 0 to 2L fx cos n pi x by L dx minus this minus iota, this iota by L, and the value of Bn. And the value of Bn was 1 by L, the whole period, integration in whole period, fx. And for Bn, it was sine n pi x by L. N pi x by dl dx. So it is nothing. It is just I have to calculate An and Bn, and then I have to, with the help of this An and Bn, I have to calculate the value of Cn. But I can solve this. I can simplify this further. This integrals, I can write this as, okay, it will become 1 by L. I am taking common from both the terms. It will become 1 by 2L. And from 0 to 2L, fx and cos n pi x by L minus iota sine n pi x by L and dx. I'm just, as the interval was same, the integration limits was same, I can club these two different integrals. In the limits 0 to 12, fx will be, I am taking fx as common, and this cos n pi x by L minus iota of sine n pi x by L, I am combining in a single term. Now again, with the help of Euler formula, this I can write cos theta minus iota sine theta. This will become 1 by 2L. From 0 to 12, fx e raised to the power minus iota n pi x by L dx. So as simple as that. I do not actually have to find the value of An and Bn. With the help of this formula, I just have to insert the value of fx. And with the help of this, I have to integrate that function along with this e raised to the power minus iota n pi x by L. Dn. Right? Similarly, for C minus n, if you recall, the definition of C minus n was half of An minus, An plus iota Bn. On similar lines, I can show that the value of this C minus n can be calculated. Okay, we will do it quickly. 1 by 2, and An was 1 by L. The value of An was 1 by L. Integration from 0 to 2L. Fx cos n pi x by L dx plus iota by L from 0 to 2L fx sine n pi x by L dx. Right? I can take this L common, 1 by 2L, integration 0 to 2L, and again I will club these two different integrals in a single, which I can write as cos n pi x by L plus, now this time this is plus cos plus iota sine n pi x by L. So you can see that this is becoming cos theta plus iota sine theta, right? So the value of Cn will become 1 by 2L from 0 to 2L fx e raised to the power iota n pi x by L. and dx. Right? So it will become 1 by 12, 0 to 12 function into e raised to the power iota n pi x by L. And Cn was 1 by 12 from 0 to 12 fx e raised to the power minus iota n pi x by L dx. So this is just the difference between the Cn and minus Cn, minus C minus n, and Cn is just take a negative, just insert minus n instead of n, right? In both of these formulas, you can also see if I replace n with minus n, then if I have calculated the value of Cn, then C minus n I can directly calculate from there. I will show you this in next example, that I just have to calculate the value of Cn. Right? So let's see a problem. Let's say a function fx, a step function, is defined 0, 1 in the range. It is 0 in the range from minus pi to 0, and from 0 to pi, it is defined something like this. Right? This function is this, from minus pi, 0, pi, plus 1. This function is this and this, a step function. Right? So for this, I have to calculate the values of Fourier coefficients. First, I will calculate value of C naught, which was 1 by 12 integration 0 to 12 and fx dx. Right? So this function was defined from minus pi to pi. So I will just insert the whole limits minus pi to pi, but you can see the value of function is 0 in the range minus pi to 0, right? And the value of function is unity in the range 0 to pi. So it will be quite simple. And of course, the total interval is 2 pi. Total interval is 2 pi. So the value of C naught will become, it will be 1 over 2 pi in the limits minus pi to pi fx dx. So it will be 1 over 2 pi. And the first sub interval, it will become 0. I am directly writing for second sub interval. That is 0 to pi. The value is 1. The function value is 1. So it will become, okay, it will become pi divided by pi by 2 pi. So it will become half. The value of C naught is half. And the value of Cn for this function, let's see what will be the value of Cn for this function. It was 1 over 2 pi from 0 to 2 pi fx, and Cn I have to calculate like this, minus iota n pi x by L dx. So again, in the first, okay, it was minus pi to pi. It was not from 0 to pi, it was from minus pi to plus pi. So from minus pi to 0, function is 0, so whole the term will become 0. So I just have to bother about 0 to pi interval. It was 1, so it will become e raised to the power minus iota n pi x by L dx. So if I integrate this, okay, this L will also become pi. This L will also become pi, and this pi from numerator I can cancel this. 1 over 2 pi integration 0 to pi e raised to the power minus iota n x by, okay, my e raised to the power minus iota x. Okay, just give me 1 minute. Okay, so this will become e raised to the power minus iota nx. And if I will integrate this, okay, it will be 1 over 2 pi.
The screen is not shared.
Okay, okay.
So screen is not showing.
So this will be e raised to the power minus iota n x by minus iota n. And limits are pi to 0. So this Cn will become, if I take, okay, it will be minus 1 over 2 pi iota n. And if I insert limits inside this, it will be e minus I n pi minus e raised to the power 0. That is 1. Right? This e raised to the power minus n pi, I just want to rework on this. This thing na, e raised to the power minus iota n pi. See, this can be written as cos n pi minus iota sin n pi. Right? And this you can see that sin n pi will become 0 and this cos n pi will become minus 1 raised to the power n. Right? And similarly, this e raised to the power minus iota n pi can also be written cos n pi plus iota sin n pi. Again, sin will become 0 for all the integral values of phi. So it will again become 0 and this cos n pi will become minus 1 raised to the power. So this term e raised to the power iota n pi or e raised to the power minus iota n pi. This term is actually minus 1 raised to the power n and nothing else. So this, if I use this, it will become Cn. It will become minus 1 divided by 2 pi iota n and minus 1 raised to the power n minus 1. Right? Now, this I can say that for odd values, of n, it will become minus 1. This minus 1 raised to the power n will become minus 1 for odd values, and overall this bracket will give me minus 2. And this minus 2 minus, if I rearrange this minus 2 outside, it will become Cn will become 1 over pi iota n for odd values, and for even values it will become 0. For even values it will become 0 because this bracket will give me 0. So the values of Cn are something like this. Similarly, on exactly same lines, if I calculate C minus n, then also I can see what will be the answer. Okay, 1 by 12, 0 to 12, fx e raised to the power iota n pi x by l. And if I insert L as pi, it will become e raised to the power iota nx. If I insert L is equal to pi, it will become e raised to the power iota nx. So this c minus n will be 1 by 2l from 0 to pi. From minus pi to 0, I am skipping that step. From minus pi to 0, function was 0. So it will become 0 to pi, function is 1, and the value is e raised to the power iota nx dx. Right. So it will become, okay, L was pi. So it will become 1 over 2 pi e raised to the power iota nx divided by iota n, and limits are pi and 0. So this c minus n is nothing. It is 1 over 2 pi iota n and e raised to the power iota n pi minus e raised to the power 0. This term again will become minus 1 raised to the power n. 1 over 2 pi iota n minus 1 raised to the power n minus 1. So again, this c minus n will become, it will become 1 over, okay, it will become minus 1 over pi iota n for odd values, and for even values it will be 0. For even values it will be 0. So from here also you can see, if I just insert minus n instead of n in Cn, then it will become minus Cn, right? But in exam, I think you should calculate both the Fourier coefficients differently, Cn as well as C minus n, and then you have to just show that yes, C minus n is nothing, but if we insert minus n instead of n in Cn, then we can get C minus n. In some books, they just calculate single coefficient Cn, right? And then they use that to express this Fourier expansion. But I think you should calculate both of these constants. So finally, if we have now the values of C naught, Cn and Cn, then I can write expansion. I can expand this function like this: Cn e raised to the power minus iota nx plus summation C minus n e raised to the power minus iota nx. Right. Now, if I insert all these values, C naught was half plus Cn was nothing. It was 1 over iota pi, and I am 1 over n I am writing inside. So it will be e raised to the power, if n is 1, e raised to the power iota x pi 1 plus e raised to the power, for odd values. It will work only for odd values. So it will become 3 ix divided by 3 plus e raised to the power 5 ix divided by 5, and so on. Similarly, for this c minus n, if I take this as 1 over pi iota pi, and it will become e raised to the power minus iota x divided by minus 1 plus e raised to the power minus 3 ix divided by minus 3 plus e raised to the power minus 5 ix divided by minus 5. Right. And if I rearrange all these terms like this, the first term, then it will become 1 by 2 plus 1 by iota pi, and it will become e raised to the power iota x minus e raised to the power minus iota x plus 1 by 3. And of course, there is one. Okay, this I am taking as whole bracket. 1 by 3 e raised to the power 3 iota x minus e raised to the power minus 3 iota x. And so there will be 1 by 5. 1 by 5 plus e raised to the power 5ix minus e raised to the power minus 5i. Okay, so this I can see this is nothing. These are nothing but this can be written as these are nothing but these are the expressions for sin x. So it will be 1 by 2 plus 2i. I am multiplying and dividing with 2i. I am multiplying this 2i and I am dividing each term inside with 2i. Right? So that this whole term will become sin x. 2i divided by iota pi and inside it is sin x plus sin. This will become sin 3x by 3, this 3. And next term would be sin 5x by. So finally the Fourier series expansion is coming like this. Now you can see that in terms of trigonometric functions, this fx is expressed in these terms, with these trigonometric terms. But if I still, okay, this was nothing. This was Fourier series expansion in terms of complex variables, iota, in terms of iota. Right. But later on, yes, we have verified that if I still able to make this complex, I can arrange these complex variables so that finally I can get Fourier series expansion in terms of trigonometric functions, sine cos. So we have both. We can express any function in terms of complex variables, and we can express any function in terms of trigonometric function. So this was the actually usage of, you can say, I can express any mathematical function in terms of complex function also. We will do one more question, a simple question on this. Let's say there is a function e raised to the power minus x, and its function is defined in the range this. Now, simply this fx can be written as Cn e raised to the power iota n pi x by L. Right? This function can be written as like this, plus summation c minus n e raised to the power minus iota n pi x by L. And of course, C naught. Right? So I want to find this integral. Okay, in this question, the limits are given as -1 to 1. So b minus a is becoming 2. So the total interval of this period is 2. So if 2L is 2, then L is 1. That means the subinterval, the half interval of this period is 1. So I just have to write, instead of this L, I can write L is equal to 1. So the calculation of Cn will be quite simple. It will be 1/2 integration from -1 to 1 e raised to the power minus x, the function, multiplied by e raised to the power minus iota n pi x dx. Right. So the calculation of Cn will be this. If I insert L is equal to 1 and if I insert the value of function, then it will be like this. So I can, this will be 1 by 2 integration -1 to 1 e raised to the power minus 1 plus iota n pi. Right. I can write this as this. So 1 by 2 e raised to the power minus 1 plus iota n pi divided by minus 1 plus iota n pi, and limits are 1 to -1. So if I take this denominator outside, it will be minus 1 over 2 1 plus iota n pi, and limits I can insert as e raised to the power minus 1 plus, okay, it was x. So if I insert the limit, it will be 1 plus iota n pi minus e raised to the power positive. Now it will become 1 plus iota n pi. If I insert x as +1 and -1 for upper and lower limit, it will become this. Okay, so this negative sign in numerator I am adjusting inside. It will become 1 over 2 1 plus iota n pi, and this term I am writing as initial term e raised to the power. Okay, I am also opening this e raised to the power 1 e raised to the power iota n pi minus e raised to the power -1 and e raised to the power minus iota n pi. Right. So both of these terms, e raised to the power iota n pi and e raised to the power minus iota n pi, these will become -1 raised to the power n. So this will simplify to 1 over 2 1 plus iota n pi e raised to the power, okay, e into -1 raised to the power n. Okay, -1 raised to the power n also I can take outside. So it will become -1 raised to the power n, and it will become e minus 1. So it will be this e minus 1 -1 raised to the power n and divided by 2 1 plus iota n pi. Okay, so this Cn is now it was -1 raised to the power n e minus 1 divided by 2, and inside I am writing as 1 plus iota n pi. This whole terms I am writing, and this 1 plus iota n pi I am taking inside the bracket, and I will rationalize this. 1 minus iota n pi divided by 1 minus iota n pi. So it will become -1 raised to the power n e minus 1 2, and it will become 1 minus iota n pi divided by 1 plus n square pi square. Right. This a plus b and a minus b will become a square minus b square, but iota square will positive. We will make that second term positive. Okay, so now this e minus e raised to the power -1, right? this I can write as e raised to the power x. Okay. E raised to the power x minus e raised to the power minus x by 2. These are nothing. This expression is nothing, but this is hyperbolic function, sine hyperbolic function, right? So this, in this, if I compare this with this, then the value of x is 1. So it will become sine hyperbolic 1. This I can write as sine hyperbolic 1 minus 1 raised to the power n sine hyperbolic 1 divided by 2 1 plus n square pi square and 1 minus iota n pi, right? This will become Cn. Now in next, from here I can directly say that the value of C minus n would be the value of minus Cn would be minus 1 raised to the power n sine hyperbolic 1 plus iota n pi divided by same denominator because it was square. And there will be no effect on this end, right? Because you can see that this minus 1 raised to the power n is actually coming from this e raised to the power iota n pi. So if I rearrange this, if I replace n with minus n in these terms, then I can see again same thing, minus 1 raised to the power n is coming as the answer. So please do not get confused. If I am writing C minus n from this equation, then why I am not using as minus n at this point, minus 1 raised to the power minus n. No, it will be just minus 1 raised to the power n, because from where it is coming, the negative sign of n does not create any change. So now we have Cn, we have C minus n, we can easily write the expansion of this function, which will be okay, summation minus 1 raised to the power n sine hyperbolic 1 divided by 2 plus 1 square n square pi square 1 minus iota n pi and e raised to the power iota n pi x. So if I, in this expression, if I start inserting the values of n as 1, 2, 3, 4, 5, it will generate series expansion of your function e raised to the power minus x, right? It will generate complex form of your Fourier series expansion of the function e raised to the power minus x.